Okay, thank you, Leo, and thank you to those of you still here in the last presentation of the last session of the last day of the conference. I didn't know people did that, so thank you for being here. I'm David Abernathy. I'm a professor at Warren Wilson College up near Asheville. And yeah, it is almost 2:30, so I'll try to keep it pretty simple. Basically, what I want to do is talk about the how and the why. So talk a little bit first about why would you want to transition from something that was going perfectly fine, a class using ArcGIS, teaching GIS, do it every semester, have done it for years. Why bother to mess up all those ready-made labs and do something different? So I'll talk a bit about that. Some of that is particular to my college. We're very small, 800 students. So some of this is applicable to us as a small college, but some of it I think is applicable to education more broadly. And then second, talk a little bit about how we did it. And I shouldn't put this in the past tense. I think we're still doing it. We're still in the process of transitioning, and I'm always looking for new, different, better ways to do that. But I'll talk about some of our initial steps. I've had 2 iterations of a course now with open source GIS. So the first question is why? And I think there's several reasons, and I tried to distill this down into one nice acronym, and I came up with this one. It is an acronym. It's also what my IT folks said to me when I said, hey, I've got this GIS lab. Can we make it all open source and run Linux and all this stuff? And they kind of made that noise and said no. They wanted, for good reasons, they wanted to maintain a consistent Windows environment across all the labs. So that was my first pushback. But the first E, this is the E that's most commonly, I think, talked about when you start comparing proprietary and open source, is expense. Now, again, we're a small college, and so our expenses weren't huge. We don't have one of these campus-wide site licenses. We have one lab, so we purchased one Esri lab kit for 20 machines. We purchased spatial analysts. We're a very environmental studies focused college, so we have a lot of students in sustainable ag and conservation biology, and they want to do raster analysis, so we had to have that. And then there's an annual maintenance fee just to keep up the software. So we're not talking major dollars, but it's enough at a small college that every year it's under scrutiny from our finance VP. So it was enough to consider the alternative, right, which is free, completely free. People say there's hidden costs behind open source, and we can talk about that, but in terms of actual college dollar outlay, it's zero. Now, Richard Stallman would, of course, say we don't want to think about free software just as in free beer, but also as in free speech. And that's what kind of got me really excited and decided to go ahead and take this plunge, is sort of the educational value of it, or the ethos of it. We're a college of, I would like to say we've had a long history of being makers. People talk a lot about maker spaces today and Arduinos and technology, but we've been making for a long time. We have a blacksmith shop. We have a fiber arts crew and classes, and people learn how to make things in there. We have a fine woodworking shop. We have a farm and a forest, and so we have cows. If you eat meat, you'll eat burgers from our cows. If you don't, you'll eat in our vegan cafeteria, right? So we have this kind of ethos of let's get together in a community and make it ourselves. And that's what open source is, right? It's not buying something off the shelf and putting it to work, but it's sort of collaborating and creating together. So that's when I got excited. I thought our students might really get into this, so maybe we should do it. And again, I think education more broadly needs to address open source. Going back to Richard Stallman, he thinks it's a social mission. It's our duty as educators to teach open source software. Not just geospatial, obviously, but all software should be used in schools, should be open source. And I think he's got a point, right? If we use software that has a black box, and we say, here, you can use this, but you don't need to bother learning what's in here, that's a detriment to learning. Versus open source, which says, yeah, peek under the hood, see what's going on. Don't like it, change it. I think this is more conducive to our mission as educators, is to do that. And there are those who say, if you believe in the scientific method, you should push this, right? Reproducibility is part of this. I'm not going to trust your results unless I can replicate your experiment. And looking at the source code is part of that. So there's a big movement now, not just in open source software, but open science, certainly open data. A lot of municipalities are really pushing open data. So I think there is this broader movement towards open and transparency. A third piece of the education is that it opened our eyes to a network of individuals and organizations, universities, and materials that we didn't know existed. If you went to the the crowdsourcing, the civic science session that was before lunch, they talked a little bit about this Geo for All initiative. And we are one of the 115 labs on there, and it really was eye-opening to see who was doing what in the open source geospatial world. So this has been really helpful to us as a small college, having access to all these resources. Another E in my acronym is ease of use. I think it's safe to say that open source software is not what it used to be. It's gotten a lot more user-friendly, and that's, thanks to thousands of developers and volunteers and collaborators out there. I think the one aha moment for me as a teacher, again, having taught in the ArcGIS world for a long time, was this. When I saw, this is a screenshot of QGIS, which is a very familiar GUI to those who use ArcGIS. But what you'll notice too is there's a window open that is opening up and accessing all of the tools in GRASS, which is a separate standalone GIS, a little more daunting to the first-time student, but suddenly you can use all these GRASS tools, and GRASS has a lot of tools that we need for hydrology and other things that I have been teaching that I couldn't do that easily just in Q. Put the two together and I felt like, aha, we've got it. I can teach. This is the equivalent of having that lab kit and that spatial analyst license for zero cost. Another E, and I didn't expect this one to be as transformational as I think it has been, is once you take the license out of the restricted boundaries of a single lab, and we had a GIS lab that we intentionally tried to keep high-end. You couldn't just waltz in there and print out a paper or surf the web. There had to be a student crew member. All of our students do 10 to 20 hours a week of work on campus, so I had a crew member who would staff the lab, or there was, I guess, academic support staff were on the hallway nearby. If they were there, the lab was open. If they were not, it was closed. So it was basically 8 to 5. Students complained, I can't get my work done. I come in at night, it's locked. I come in on Sunday, it's locked. And so by allowing us to switch to open source, we suddenly have transformed that. Suddenly we see students in the library on their Macs doing GIS, right? You didn't see that until this past year and a half. So we put some computers in our library that are open 24/7. There's one section of our library open all the time, so we put software on there so students can work on GIS even if they don't have their own laptops. So suddenly the number of licenses of software exploded on campus, and it's made a huge difference. I can give lots more homework now, because I know they'll be able to work on it at night, right? Also, what's amazing to me is the extensibility of these software programs. There's so many different pieces and plugins and things you can grab to apply to your own specific needs. Not that that's not the case necessarily with proprietary, but it amazed me in the open source world, the number of Python plugins that you can access. Or if you don't find what you need, you can create one. Even more amazing to me, we've started using the R, statistical programming language, as a GIS. So we at least introduce students to it. This one maybe fudges a little bit on the ease of use. It's a little more daunting for students. It's command line. But there are more than 10,000 packages you can download and use in R. And I tried to fit all the ones that started with the prefix geo onto a screen, and I couldn't do it. I got down to geosphere or so. It's amazing what you can do. And students, after they get over their fear, they think it's cool. More than one student says, I feel like I'm magic because I type a couple lines of code and it looks like I've done something in a full-on GIS desktop. So we're trying to push R a little more because I think it's got some real power. And the final E, and I put an exclamation point after this one, is employment, right? Obviously, as an educator, I want to see my students go on and be successful. They want to go out and be successful. I tend to not see students in my GIS class until they're seniors because they start thinking about jobs. And one of the pushbacks here that I've heard a lot is, well, you really need to teach Esri because that's what they're going to see when they go get jobs. And I'd love to hear from folks to see, there is some truth to that, but I've been asking around, and to me, it seems if we teach open source, and especially something like QGIS, which feels a lot like ArcGIS, there should be some transferability. And actually, Scott Barnwell, who was here at the conference at City of Asheville, hired one of my former students, and he agreed. He says, we actually now almost test for this experience when we hire people. He hired one of mine above a lot of other candidates, he said, exactly because he had worked in some open source. He knew what GeoServer was. He knew what QGIS was. So I think it's actually becoming a benefit, not a detriment, to teach open source at the college level. Okay, so Now I'll talk a little bit about how we tried to transition to open source and some of the roadblocks. This is where OSGEO Live comes into play. Anybody know what OSGEO Live is? It's really cool. It's basically all bundled up into one. It's an operating system. It's a bunch of geospatial software. I think desktop GIS alone, there's 6 different packages. Also web mapping, database management, all kinds of tools, and a bunch of tutorial data, and some quick start guides, and a community that supports it. So basically my idea was to do this, right? This is OSGEO, this is 9.5. If you go to the website, they're up to version 10. So they're also updating this and tweaking it pretty quickly. But my idea was, I went to the IT guys and said, I want to install this on all the machines. They said no. So, but this is what it is. It's a desktop that students are familiar with, even though it's Linux. They may not have touched Linux. It feels very, very intuitive to them. Open folders, access tools, and you can quickly boot up QGIS from right within OSGEO Live. And this is the other great thing, because of our good friends at NC State who developed a lot of the tutorial data for GRASS, a lot of North Carolina data already baked in. So I can just quickly pull up a county map. There's a lot of stuff in particular to Wake County, but a lot of statewide stuff as well. So it felt like this should be pretty easy. Because the IT staff said, no, you can't install it directly, the other cool thing about OSGEO Live is you can put it all onto a DVD or a USB thumb drive. Even though it's an operating system and a bunch of software and a bunch of data, it fits onto a USB drive. So I thought, okay, that's what I'll do. I gave a nice lecture to my students that I'm not going to make you buy a textbook. I'll give you all the materials, but I want you to buy a high-speed 32 gig USB stick. If you do that, bring it in. I'll get you load this all up, and then there is the inherent danger of losing it. But I thought we'll be able to. We can back the data up. So just try to keep this with you. Bring it to class every day. Boot up the Windows machine into Linux. So I did that. They come back. I said, come back next week with your USB sticks. And this is literally what I got back. One looks like it came out of a cereal box. They had rummaged our free store. So the first challenge then, a couple of I had to send away and just say, that's just not going to fly. Others I said, well, this will work, but you'll be frustrated while you watch your neighbor boot up twice as fast as you, but it'll work. So we all loaded up OSGEO Live. They came in, booted up, did their work, and it worked okay. But as you would expect, some people would forget them. Some of these just kind of died halfway through the semester. And there were a couple other problems that just seemed pretty random. So I thought, this is not sustainable. We can't teach the class this way. So the next step was plan B, well, really plan C, because my desktop version didn't work either. We ran OSGEO Live as a virtual machine. So instead of having them carried around on a USB stick, I had our IT folks just put it onto the Windows desktop. So they could boot up Windows, then they click an icon, and you've got another entire computer inside your operating system. I stole this from the web because I forgot to get a screenshot from our lab. But essentially, you're running Windows in the background, you click on an icon, and you're running Linux in a virtual machine. That works pretty well, and we're still doing a variation of this today. The problem is our machines are a little aged. They're overdue for a refresh, and so if you're running Windows, and then you boot up Linux, and then you boot up GRASS, and then you load rasters, you start to chug. So not ideal. I think when we get a lab refresh, this will work pretty well. But for teaching purposes, for the first half of the semester, this gets the trick done. So this most recent iteration of the class, I went to plan C, which is to keep that Windows desktop, so my IT folks are happy, boot up OSGEO Live in a virtual machine if you need the tutorial data or want to use the software there, and then we added standalone packages in Windows. The ones that we mostly use in class are QGIS, GRASS, and I added R Studio, which makes R a little less daunting because you have a graphical user interface that it makes it a little bit nicer and not so scary. So this is our current setup where if they want to boot into OSGEO Live, they can, and they have lots of help and tutorial data, or they can, once they start working on independent research projects, they tend to find the tool that they want to use. And I give them some leeway there too. Once they have a project, they can choose the tool they use to apply for their projects. So that's kind of where we are now. I'll talk a little bit here about takeaways and next steps. First, next steps, we have a second course on the books that's sort of a second step in GIS, an advanced GIS course, which I have not yet transitioned to open source. because I haven't been able to offer it in a couple of years, so I'm hoping to do that over the summer, is get it in line. Now that students will be coming through intro and open source, they're going to expect to stick with it. So that's an obvious next step. Second, this is related to the fact that my machines are a little old and decrepit, and I don't know that I'll get new ones this next budget round, is we're looking at maybe putting all of this on the cloud, running it on Google Cloud Platform or Amazon, and just that way, as long as we have a decent internet connection, students just log into their account and they've got everything right there. I'm working on that this summer as well, and we may try to give that a shot in the fall. And the third is to sort of work with other departments and coordinate our software. Right now at my school, if you're a psychology major, you'll learn SPSS. If you're in math, you might work on MATLAB. And if you come to GIS, you're working in R. So we're talking about maybe we should find some standards across the campus to get students better versed in these software programs. And we're proposing a minor in data science that I think will help that, help us get things like R standardized across the campus. So we'll see where that goes. And then for me, some of the takeaways, this is all sort of anecdotal. I haven't had enough data to sort of really crunch the numbers and see how effective we're doing in terms of pedagogy and are students learning more. But I get the sense they are. They did, as I expected, embrace the philosophy. They really get into that. I have them write about this, and they very much get the difference in sort of hierarchical commercial software versus collaborative open source software. And they seem to enjoy it. Some of the student evaluations say they liked not just focusing on one, but learning a few different tools. We do GRASS, QGIS, R, and some web mapping in the intro class. And echoing what Scott Barnwell said, I think they're learning some and I am. This should be teaching and learning flexibility, adaptability, and persistence, right? We don't go in expecting everything to work flawlessly and get mad when it doesn't. We kind of expect to hit some bumps. And part of what I try to teach students is I don't ever want to see hands go up. I want you to just like dive in or ask your neighbor, figure it out. And I don't have any hard evidence of this, but I feel like the students are coming out more flexible. I've seen them actually, if they run into a roadblock in one software package, they'll load the data in another one and see if that one has the tools. And I think that's valuable. Again, the increased access piece, I underestimated how that would change sort of our culture of GIS at Warren Wilson. I see people will stop me in the library and say, hey, I'm working on my map, can you come help me? And that's great. That's never been possible. And our students, again, all of them do 10 to 20 hours of work on campus. Some have off-campus jobs. They also have to do a lot of service. We have a work, service, and academics triad. So they're busy. All students are busy, but they're very busy. So they appreciate being able to do GIS at 2 a.m. if they can, if they need to. And finally, going back to that sort of maker space idea, I think open source really encourages tinkering. Once they learn that, oh, there's these packages, or you can write plugins, you can actually tweak the software to your own needs, they get kind of excited about playing. So we started, I think, bringing that maker identity more into the technological world. I had one student start to play. We built a tech lab in the library, and this student was trying to build a weather sensor node with Arduino code and some open source hardware. And we had a whole class on emerging technology where they were using software and hardware to just build things. And so we called this our technology sandbox, just a bunch of things there they can come mess around with and play with. And then my one, I guess, case study that I can quote, Armin here, was the only student I've had who's taken both iterations of the class. He took intro to ArcGIS and got so excited about GIS, he took the intro class again with open source. And I told him he could for credit because it would be different enough. And so I emailed him the other week and said, hey, can you just tell me what you think, having taken both classes? And he is now working for an arborist and a forester and trying to start up his own consultancy. And he said, basically, I have to use Cube from a financial standpoint, but he really has found that it has not limited his ability to do the work. So again, my case study of one shows that this is working. And another takeaway, and if you'll excuse my shameless plug here, but as I was developing these classes, I got so into all these tools that I ended up sort of writing a book along with it, thinking about and putting lab exercises into here that I wanted my students to use, and I actually used them as guinea pigs. I'm like, do this R chapter and tell me what you think. And they did it and gave me feedback. So in conjunction with the transition, I was able to put this together. And there's been a lot of drones around here today, so I'll close on a drone shot of our campus as we're setting up for homecoming. We have been doing some We actually started balloon mapping before we got a drone, just a helium balloon and a camera, to get some imagery of our farm to put into GIS. And our forestry professor wants us to start flying to get imagery of certain forest patches on campus as he tries to think about education and also thinning the timber and that kind of thing. So with that, I think I'll stop and see if there are any questions. Everybody wants to go home. Yeah.
Of the 5 or 6 or so uses, was there one that was sort of the most cumbersome to get over? Or, you know what I mean?
Well, I mean, I may be overstating ease of use a little bit. Again, especially when you get into R, because I find that our students are still daunted by the command line. And so actually one thing, though, that I would backtrack, I don't think I have a good screenshot of it, but GRASS is a great tool for getting students a little less shy of command line, because when you run GRASS, you're clicking buttons, but it writes the command line for you. And so I show them that, like, you just wrote that line of code, so now actually write it and make the same thing happen. And they start to realize and see the connection between the buttons and the code they're writing. So I'd still say the ease of use problem is it's not quite as easy as just focusing just on ArcGIS, but again, a lot easier than it used to be.
I think it's really great to let the students take that tool with them. Because so many of our students, their design students will go into a firm where they're doing research on something, but that firm or that architecture firm doesn't really and so they've been hired because they have this tool, they have this skill, but then the office doesn't have the tool.
Right.
They're coming back on campus to use it, they're trying to find someone who's going to be able to use it. But this is a great way to empower them to do something different.
Well, yeah, you're right. It is empowering, and our students, a lot of our students go on to work in nonprofits and conservation and organizations that don't have those resources. I had a student put about 40 hours of work into mapping for a land trust coalition, and it wasn't that we were taking away business from a small shop. They said it's either we use you or we don't do it. And so, yeah, I think having those tools available for people to use who just don't have the resources. I mean, I think things have gotten cheaper and nonprofits can get cheaper access to licenses, but it's still, I think, to have a student who's well versed in these tools and can bring them directly into an organization, it's powerful.
What if anything you see other
Good question. The question is, are there any limitations to this? To be honest, I don't think of any. I mean, again, I still occasionally hear that pushback that, well, we're an Esri shop, and so we want them to have ArcGIS experience. But as Scott said, he's found that you can easily get that if you've learned. To me, another positive, that's not your question, but another positive is that students learn they seem to me to learn the concepts better when they have to think about not just what does this software program do, but what am I trying to do with data? And do I need to move it over here to do what I'm trying to do, right? So I hope they learn the terms and the functions and the tools, and they should be able to move across any of them. So no, I mean, there are those, if you get to a bigger institution, and from an IT perspective, that's probably a limitation. Again, they didn't want to manage a Linux lab and a Windows lab. So if you're trying to be more enterprise level, it can be more challenging. I'm not doing any big data servers and that kind of thing, but from a teaching perspective and a student perspective, I think they're ultimately learning more, I hope. All right, thank you.